The duration of two different brands of battery A and B is tested. 50 batteries of each type are randomly selected and tested in the same way. The duration of each battery is then recorded. The results of the test are shown in the tables below. Calculate an estimate for the mean and the standard deviation of both brands of batteries. Well, there was already a video on showing you how to find the mean. However, we'll just quickly go over it again. So it's type A and type B. So estimating the mean, so what you do, type A, and then what you do is you take the midpoint of each of these. So that's 2.5, 7.5, 12.5, 17.5, 22.5, 27.5 and 32.5, and then you work out x times the frequency, so it's 3 times 2.5, 7.5, 37.5 and so on. So you work these all out. We've done this once before. Right, and the mean is going to be the sum of xf over sum of f. The sum of f is 50, and the sum of xf is 945. So it's 945 divided by 50. It gives me 18.9 hours. Then the same for type B. It's exactly the same thing. Also working x times f for each one. And then total is 50. This total here is 915. So we've got 915 divided by 50, 18.3 hours. Right. So now to do the standard deviation. So we'll just type A. So remember the mean we just calculated was 18.9 hours. Same table, we use the same idea, midpoint again, and then we need to work out how far each thing is away from the mean. So we need to do 2.5 minus 18.9, it gives you that minus 16.4, 7.5 minus 18.9, 12.5 minus 18.9, etc. So working each of those out. Last one will be 32.5 minus 18.9. Now, because some are negative and some are positive, we can't really take the average of that, so we need to square them. So squaring each one of these, so it's 268.9 is 16.4 squared, to make them more positive. Now, because this one occurs 3 times, because the frequency is 3, we need to multiply it by 3. So we need to do 3 times 268.96, which will give me that, and then we need to do 129.96 times 5, etc. 40.96 times 8, 10 times 1.96, 12 times 12.96, 73.96 times 7, and 5 times 184.96. And then what we do is we add these up. This is 50, and the total here is 3,402. So this is the sum of f times x minus x bar squared. Now, the standard deviation is the square root of sigma f of f times x minus x bar all squared divided by sigma f. So the top number here is given by this, and this number sigma f is given by 50, and that gives you 8.2486, which to 3 significant figures is 8.25 hours to 3 significant figures. Now, there is an alternative formula for this as well, which is very similar to the other one. I'm going to do it without proof. So x bar is 18.3 hours. The alternative formula would be this: square root of sigma fx squared over sigma f minus x bar squared. So again, we would need the midpoints, and this is the one you would use from your GDC as well. You would need to work out x squared for each of these. It's 2.5 squared is 6.25, 7.5 squared is 56.25, etc. Working them all out. For example, the last one, 32.5 squared, will give me 1056.25. This one occurs 1 time, so we need to do 1 times 6.25, that gives me 6.25. This occurs one time. This one occurs 10 times, so that will be 1562.50 multiplied by 10. 23 times this one, 7043.75. 9 times 506.25, that's 4556.25. 4 times 756.25, and then 2 times 1056.25. And then what we need to do is we need to sum these up, because we want the sum of these for the formula. So you just put the numbers in the formula, we get 18362.5 divided by 50 minus the mean squared, which we just calculated, which is 18.3 squared. Instead of square root, we get 5.68858, which gives me 5.69. Now, if we had to make a comparison here, this number is much smaller than the 8 point sum we got for type A. So this battery would perhaps be more reliable, even though its mean is slightly less. Okay, so you could label type A as the longer lasting battery, and then you could label type B as the more reliable battery because its spread is less than the first one. This is how it works. Now, of course, this can be done using the GDC. So going to the GDC, and we need to select spreadsheet mode. Okay, so in here we're going to call this one X and this one F. I'm just going to do type A to begin with. So we'll put in 2.5, enter, 7.5, enter, and then put the cursor there and then do shift this one, and that selects them all, control menu, and then press fill, and then scroll down, and you can use the arrow key there, the arrow key here, to scroll down to where we want. We want to go down to position 7, press enter, and oh, we made a mistake there. Let's just go back. I think because the original numbers are wrong, because it's 7.5. So let's just do it again, 7.5, and then I need to do it again. So fill those. So shift that one. Oh, we're having a right problem now. Shift that one. Control menu, press fill, and then scroll down to position number 7. So use the arrow key, press enter, there we go, we've got the right information. Just shows that you should always check what you're doing. Right, putting in the frequencies for type A, 3, enter, 5, enter, 8, enter, 10, enter, 12, enter, 7, enter, 5, enter, and then scrolling back to the top, and then doing menu, statistics, stat calculations, one variable statistics, press enter, forget the number of lists. Here you want it to consider the X list, which is that one, and then you want this one to be the frequency list, and it will put it in the first available column, which is C, and you can see we've got 18.9 for the mean. When we sum up all the data, f times x, we've got 945. When we did the sum of f times x squared, we've got 21,262.5. And then this one is always the second one. It's never this one, it's this one here. It's the standard deviation, the one that says sigma x. This symbol means sigma x. This is one you're interested in. You're never going to be interested on this one. It's 8.25. Now, instead of actually doing all that again, if I just change the frequencies to the type B, I can get that as well. So it's 1, 10, 23, and you'll see that all the information will change automatically. 9, 4, 2, and then we'll get some more familiar information here. So we'll just scroll back up to the top. Again, we see that the mean is 18.3, is what we got before. The sum of all the data was 915. This was the sum of f times x squared, which was 18,362. And if we scroll down, we got the mean here of being at 5.67. So going back to this, Here's the screenshots, and from this we can get the information we want. So x bar is sigma fx over sigma f. Always write down the formula if you're going to use it. Yeah, so we get that from the calculator. So that's 945 divided by the number of items, which we can get lower down, which is 50, which gives me 18.9 hours. Standard deviation, sigma fx over sigma f minus x bar. So that's going to be sigma fx is going to be 21,262.5 divided by the 50 items there is minus the mean squared, which we just calculated, and the answer will be that. So this is information you can put in for the exam. You put all this information in. X bar is going to be sigma x for b, sigma fx over sigma f, so that's going to be a similar sort of thing. 915 divided by 50, get it from the calculator, is 18.3 hours. Again, we got that from the calculator. And then for the standard deviation, we get square root of sigma fx over sigma f minus x bar. This comes from here. So that's going to be 18,362.5 divided by the number of items, which is 50, minus the mean squared, which is 18.3 squared, divided by 5.69 hours to 3 significant figures. So don't forget, if you scroll down as well, you can scroll down, you can get the number of items you need, which is 50. Okay, so this has been a video to show you how to find the estimate of the mean and standard deviation from grouped continuous data.